A block of mass 1 kg just remains in equilibrium with the vertical wall of a cart accelerating uniformly with 20 meter per square second as shown. The coefficient of friction between block and wall is. So here we have to find the coefficient of friction between what and what? Between the block and the wall. So what we are seeing in this picture, this is a cart, right? And this cart is accelerated in this direction to the right with 20 meter per square second. And we are seeing a block like this, which is of 1 kg mass. And in this situation, during the cart is accelerated to the right, this block of mass is said in equilibrium, right? This block is in equilibrium, this said here. That means it is not falling down. How it is possible? Yes, this is possible when the friction between the wall of this cart here, right here, okay, so at this point, at this edge, when the friction becomes equal to the weight, we can understand it just by putting some vectors like this, so downward is weight and upward is the friction, right? So when this weight is balanced by the friction, so definitely this block will be in equilibrium. One more thing we have to understand, during such situations the friction depends on the normal reaction due to the wall. So for that I simply choose such a kind of one vector which is a normal reaction right here, okay. So normal reaction, from where this block is getting this normal reaction, this is the reaction from the wall at the interface, right? So where the body is in contact with the wall. Here what is happening, there is a kind of pseudo force. Here will be the pseudo force, say Fp, which is pseudo force. This pseudo force will appear only because the cart is being accelerated to the right, okay. So when the cart is accelerated to the right, the this block will get a pseudo force to the left, and this force will produce such a kind of an interaction here at the wall, so that the wall will produce a normal reaction on the block, right? So that is N. Here the physics is, what you must understand is the frictional force, right? The frictional force is given by coefficient of friction into the normal reaction, okay. Coefficient of friction multiplied by normal reaction. But what actually this N is? This is normal reaction due to this wall, So wall is putting a force on the block which is opposing its pull, that is this one, which is N, right? So normal reaction. Then how we can write this N? N is equal to the magnitude of the pseudo force. Definitely we are having no equation or any expression for pseudo force, but we can write it like this, mass of the block into the acceleration in opposite direction, okay, in opposite direction. So pseudo force is acting to the left, whereas this acceleration is acting to the right. But we see we are simply using the magnitude 20 meter per square second for this term A. And what actually this M is? This is 1 kg, right? And this A is 20 meter per square second, which is given in the question itself. Therefore, what I can write for N? So N is simply 1 into 20 Newton, which is simply 20 Newton. So this is N, right? So now I got this N. So definitely what I can write next, I can simply write F is equals mu into N. N stands for 20, right? So many newtons. But what is my target? My target is to find this. Well, still I have to do something more so that I may get the some value for this F. How it is? So this is just by seeing at the picture earlier what I said. So friction is balancing the weight, right? So friction is balancing the weight. So now I am doing that. So friction is balancing the weight of the body, that is magnitude of the weight. So how much it is? It is mass into acceleration due to gravity. So mass of the block is already known, it is 1 kg, and how much you should use g, which is given in the question, that is 10 meter per square second, right? So now I am using 10 here, so definitely it is 10 Newton, right? So friction is 10 Newton. So what happens to the value of F here? This will be 10 Newton, which is equals mu into 20. That means what I got? I got U is equals, it is 10 divided by 20, otherwise it is half. So definitely mu is 0.5 with no units, right? So the value of the coefficient of friction is now, it is option 3, which is 0.5.